Good. So I start with this document in absolutely all my classes. Why? Because this is even below the foundation. Okay. So what is below the foundation? The foundation slab. What is it? Just the digging of the hole, right? For building a home. So this is the bread and butter of algebra. And these are three different situations that I would like us to work on, remember forever, and possibly not go back to re-explain and re-explain and re-explain. I hope that that's not going to be the case. But of course, I will always answer your questions. So today is already okay, February the 4th. Good. So let's start with a plus b and analyze this and see what it is and why is this so important. And there will be not one day in which we do not use these three special products. Okay, can anyone tell us how is this called? Yes, please, Danny. So first of all, what is this a plus b? How many terms are there? Two terms, and what is it called? Excellent, excellent. This is indeed a binomial squared. Excellent, good. So then, can anyone give us the answer if you remember, or what does it? Yes. No, that's okay. It's okay. Yes, please. That's the starting point. Although I don't ever want to use this again, but this is what I wanted at first. Perfect, thank you. So this is a binomial times another binomial. And we're going to use which method? The FOIL, very good. We are using FOIL. Good. So a times a, very good. Copy the base, add the exponents, plus a times b, plus b times a, also ab, and times b times plus b. This is math 001. Okay, I'm kidding. This is the basics. If you don't remember any of this, we may have to spend more time outside of class.
I understand everything you're doing. I think
so a times a is a squared, a times b is ab, b times a is ab, and b times b is b squared. Please stop me if you have questions. Okay, so now we combine these two because they are like terms. So a squared plus 2ab plus b squared. So then a binomial squared has how many terms?
Just two, right?
Let's look. How many terms?
Oh no, it's three.
3 terms. So it's a trinomial. This is something to write super important in your notebook. So whenever I ask you what is a binomial squared equal to, you will never say a squared plus b squared, but you will say a trinomial, excellent, and you will say a squared plus 2ab plus, excellent. However, this is not how I should remember it, because I will not get a and I will not get b. Here's what I will get. A first term plus a second term. The first term can be 2x squared y cubed. The second term can be ab to the 4th. I don't know. So what is the pattern that I just learned? What is this? The first term squared. Very good. Awesome. Plus? Plus? Plus 2 times? The first term times?
Second term.
Excellent. Plus?
Second term.
That's it. This is how I have to remember the pattern. First term squared plus 2 times the first times the second plus the second term squared. This is something super important, and moving forward, we're going to use this over and over. Now let's look at an example and see how we apply this. Let's say 2x plus 3y squared, everything squared. Yes, you can say, why don't I foil? Yes, that's fine. But you will be left behind because foiling should not be part of this class for this particular special product. Why? When we get to factoring, we're going to have difficulties going backward. So this way is distributive. But what is going backwards? Factoring. If I understand and remember the pattern, the factoring will not be an issue. So can anyone give us the answer without foiling? Remember, this is the first term now, and I have to square it. Then I have 2 times the first term times the second term times plus the second term squared. So the first term squared, please.
2x.
Remember, I have to square 2x. I cannot pick and choose. This is a product of 2 factors. I must square both factors. Yes. What will be this?
Is it 2x?
I have to square both factors. So this will be 4.
4x.
Very good. I completely agree. Plus.
Squared. Plus.
Remember the 2. I have to multiply 2 by 2.
9.
2 times 2.
4.
Times 3. Excellent. Times x times y squared. Plus. And now I have to square the second term. So let's square 3y squared squared and see what we get. 9 indeed. Yes. So can anyone refresh our memory on the exponential rule? When we raise y squared to the second power, we copy the base, and what do we do with the exponents?
And
Multiply.
I have a question.
Yes.
I think so. I don't know where everyone is in math.
Sure, of course.
So it's been a while for me taking algebra, but I think I'm just skipping because I had I made mistake in row 3, but it was 9y4, but I'm skipping something. I think I'm just like doing it in my head then.
No, you're just squaring 3y squared, or if you can say 3y squared times 3y squared. 3 times 3 is 9. Y squared times y squared is y to the 4th.
Or I could have just because of the 2 times 2, and then add the square, and then know that because it's squared 3 times 3, and know to multiply
The power times the
The
power.
power.
Correct.
I can do that.
Yes,
Okay.
because that's the exponential rule.
Okay.
Exactly. Any questions on this? Is this okay?
No.
Which part is not?
I think you threw me off when you started off doing the foiling with the first binomial, because that part I understood.
We don't want to foil.
Yeah, I get
Yeah, we
that.
want to yes, we want to be able to understand the pattern and remember it. So all you have to remember is this, and say it several times. First term plus second term squared is first term squared plus 2 times the first times the second plus the second term squared. If you say it 10 times on your way back home, you'll remember it.
Say it again.
First term, this is what I'm saying. I'm reading from here.
Okay.
First term plus second term squared is the first term squared plus 2 times the first times the second plus the second term squared. It's based on what we just determined by foiling. So I copied from here. Yes, exactly.
So
for
that's just
any
the
binomial.
formula.
Exactly.
Okay.
So once I understand the pattern, I can use it on and apply it on anything. Very good question, actually. So that's why I want you to understand the pattern and then apply it to anything you want. So this is our first. So I'm going to write first term squared plus 2 times the first term times the second term plus the second term squared. What we just did here. I just copied it one more time on this form. Yes, please. Yes. 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12.
We can't see where you're tapping
Right? 2
Also,
times
you always
2
will do
is
2
4.
times.
4 times 3 is 12. It's all multiplied. It's multiplied.
The 2 always in.
Is that better? Good.
I understand what you're saying, but the class I took, my teacher, I had a hybrid class, so we kind of almost like
Did
uh,
on our
we
own.
did it on our own, and I never used this way. She told me to, but I
You
never
can use
understood
any
it.
method you like, but if you continue to foil, you're gonna be fall. You're gonna fall behind.
Yeah, I get that. I just have to get used to this
Yes,
one.
yes. Adjust, make some adjustments, and see what is best for you. Okay. Can anyone give us this formula now? Yes, please.
So with the 2 times 2, you don't do 2 times 3? I mean, you don't do 3 times 3?
It's not a distributive law. It's a product. It's a product. So the distributive law. So these are the two situations. 2 times 2 times 3 is one thing. 2 times 2 plus 3 is a different thing. You're talking about this, but there's no plus. So we're not using the distributive law, which would have been 4 plus 6. 2 times 2 times 3. It's 2 times 3 times 2. It's 3 times 2 times 2. So this is 12. I'm not distributing. It's a product. Very good question, actually. So that's the difference between the distributive law. The distributive law requires multiplication and addition, but there is no addition in there. All I have to do is multiply 2 by 2x by 3y squared. 2 times 2 is 4. 4 times 3 is 12.
But you gotta know the rules.
And then xy squared. Say it again.
You have to know the rules in the beginning.
Once
though,
you
right?
remember the rule, then yes. No, her question was something else. How come that I don't multiply 2 by 2 and then 2 by 3? I can't.
No, so I was actually talking about the exponent. Before, remember you guys.
Oh, which exponent?
So the 2 on
This
the
one?
outside of the, no, on the first part. So that 2, I thought we were supposed to square, so 3 times 3 for that second. For the
Yes.
y, and then 2 times 2. But I thought for the xy you do 2 times 2 and then you do 3 times 3 and then you add those. Am I?
In the middle?
Mm-hmm.
In the middle, I have 2 times 2x times 3y. 2 times 2 is 4. 4 times 3 is 12. And x and y squared have to be copied.
Okay.
So the middle term is this. Better? Good. So now I'd like to go back here. We just have to work on this and move forward. Okay, so what do you have here? Yes, please.
A squared minus 2ab plus
Very good. The only difference is the positive here, which is positive in the middle, and the negative here, which is negative in the middle. And how will I write it with the first term minus second term squared? Because I need a bigger idea than just a and b that works, right, for us in all situations. You will say first term squared and minus
2 first term
times the first term times the second term and plus the second term squared. This is the pattern that we should remember, not just a and b. Of course, you can still remember it with a and b, but I want you to understand that you will not be given a and b. You will be given anything, and it will work for anything you want. Okay, can anyone give us an example with a difference? It's the same thing with minus. It's exactly the same thing we wrote here, but with minus. Identical. With minus, minus here, and minus here. I'll come back to that in 1 second. Okay, can anyone give us an example with a difference? Anything you want. It's the same thing with minus. 2x minus 4y to the third. Good. First term squared. Minus. You cannot put another minus and say, okay, it becomes plus. No, if it's minus here, it's minus. The signs are taken care of already. 2 times the first times the second. 2 times 2 is 4. 4 times 4?
16.
Very good. X, y cubed. And now plus. The last term. 16y, copy the base, multiply the exponents. 6 indeed. This is it. What I would do if I were you, I would make up, and this is my request, I would make up 2 examples here, 2 examples here, and work on them. You can check your answer using FOIL if you want to. but you should definitely practice. Okay, the last one. Here's the last one. A plus B, A minus B. What do you think the answer is for this one?
Are we trying to convert it into a binomial?
It is a binomial. That's true. Yes. Let's this time FOIL it, and moving forward, we'll remember what it is. So A times A.
A squared.
Very good. A times negative B.
Negative.
B times A plus AB. Very good. And positive B times negative B. Very good. What do we notice?
It's just they cancel each other out.
So this is not a trinomial, right? So when we multiply two binomials that are identical but they have opposite signs, this is the difference of squares. Good. So moving forward, we will say the first term plus the second term, an identical first term but this time minus second term. What will you say forever moving forward? Second term squared, whatever it is. Very good. So can anyone make up some examples for us? Let's say 3x squared minus 4y cubed. What will be the next one? If I want to use this particular special product.
3x squared plus.
Exactly. Otherwise, I cannot use it. They have to be identical, and the difference is one has plus, one has minus. Good. So now what will you do to get the answer?
Multiply.
First term squared, which is 3x.
Careful. We have to square everything.
Sorry. That will be then 9x x to the fourth
Perfect.
minus 16y.
Copy the base and yes, then multiply. Very good. So we will factor. We will I will refresh your memory on factoring. Hopefully next class, because we're going to be given this and we have to come up with that. Yes.
Just for clarification, we're adding the exponents?
Multiply.
Okay.
Depending on what you're doing. Okay, you have two options. One option is 3x squared squared, and the other option is 3x squared times 3x squared. Both have to give us the same answer. I square 3, I copy the base, multiply the exponents. I multiply 3 by 3, I copy the base and add the exponents. I'm sorry, that's what I meant. Multiply the exponents, add the exponents.
Okay, I think I got confused when I saw the 16y to the 16y.
Yeah, so we have two options, 4y cubed times 4y cubed, which is 16y to and add the exponents. Or you can say 4y cubed squared, copy the base, multiply the exponents. And you still get the same thing. So there are two options. You either say you square or you multiply two identical quantities. Both work. Very good. So coming back to our explanation here, our document, it's a squared minus b squared. So I'm expecting this to be our first agreement. It does not have an expiration date, and you can never forget about it. So when you asked a question like this, I'm going to say we have an agreement, and somebody else will answer. I'm kidding. I am going to answer your question. But I will remind you that we have a signed agreement. It's signed virtually, but still signed. Any questions? Do you think we need more examples from these three special products?
Yes.
Okay, which one? Give us one.
Can we do one more each one?
Please choose.
Okay.
Anything you want.
Okay, so let's do the third one again. No, but one like number 3. I'll give you numbers.
Whatever you want.
Oh, okay. So let's do 4. So 4x squared, right? Plus 2y y squared, and then it has to be identical, right?
Correct.
Okay, so 4x squared plus
Careful.
minus 2y squared.
Very good. So then the answer would be
16
yes.
x
4
Very good.
minus
Yes.
4
Yes.
y.
x 4 4.
Good. That's it. That's all you need to do. Well done.
I wish I would have knew this last semester when I was struggling.
Well, you should have called me. Now you have my number. Okay, very good. Any questions here? Any questions? Okay, I would like to start with 1.1, which is all about how to use a graphing calculator. Well, we're going to use the graphing calculator throughout the, the semester, so I don't want to do a lot. However, if you find when you work on the homework in 1.1 in my math lab, if you find anything that I should present in class, I will. Okay. What I would like to show is, let's say, a graph of a function, because you're going to see this in chapter 2 as well. But let's say the graph of x squared minus 4. Does anyone remember what type of function this is? No. We're going to see it again and again and again. This is a quadratic function. Or equation if you want. What does it look like? Does anyone remember what is the graph of a quadratic function?
Isn't it like a slope or a line?
Careful. It's linear. That is linear. We're talking about quadratic. Careful.
Parabola.
Correct. It's a parabola. So x squared is a parabola, and then x squared minus 4 will be pulled down. Now, let's say we are told, or we want to adjust the viewing window. And this is what you will see. Let's say I have -6, 4, 2. And let's say I have -10, 4, 2. What does this mean? The viewing calculator, the viewing window of the calculator, I'm going to show it to you in a minute, will have a horizontal, an x-axis, and will have a y-axis. The x-axis will have -6 till 4 with a tick of 2. So -6, -4, -2, 0, and 2, and 4. That's what the unit would be of 2. What about the y-axis? From -10 till 4, again with a tick of 2. -10, -8, -6, -4, -2, 0, 2. So let's do that with the graphing calculator. So in y equals, I'm going to punch in, this is the x key, x squared minus 4. I want to adjust the viewing window as I was told or as I picked. So let's go to window. And I said -6 up here. When we start with negative, we always have to use this negative, not the operational negative. So leftmost point on the x-axis -6. Then I said 4. I think I said 4 with a scale x scale of 2. Then y minimum, -10 is fine. Y maximum is 4, and I want the scale of 2 again. And then I click on graph. So here's the graph. It's coming from positive infinity. It crosses the x-axis at -2, 0. It crosses the y-axis at 0, -4. It crosses again the x-axis at 2, 0, and goes to infinity. We're going to look at these graphs. Can anyone remind us of what is the domain of this function? What x values you can plug in?
anything with
Anything.
Yep.
Anything. In x squared minus 4, I can plug in anything. I can square and subtract 4. What about the range? From the lowest y value to the largest y value. From negative 4 to infinity. Negative 4 to infinity. X-intercept. Negative 2, 0, 2, comma 0. Y-intercept. 0, comma negative 4. Can I say that this function is decreasing and then it's increasing?
Yeah.
For which chunk of the x value is it decreasing? Not from which value to which value. For which piece of the x-axis is the function decreasing? From negative infinity till,
to negative 4.
not from which to which. For what chunk of the x-axis?
Okay. To
To
positive.
0,
0.
the function is decreasing.
Okay.
And for what chunk of the x-axis is the function increasing?
0
0 is
Two.
infinity.
infinity.
Yes, we're going to see that too. So that's really all I wanted to say about 1.1.
Well, that's it.
That's it. So I would like you to discover for me and say, there is another problem here, and I wasn't sure how to do it. Okay? But now you know what they mean when they give you something like this. What do they give you? They have the leftmost point for x, the rightmost point for x, and the scale. The leftmost, the bottom for y, the top for y, and the scale. So when you see something like this, you will know how to address it, correct? Perfect. Moving on. Where is, oh, my pages are here. Good. Next. 1.5. I'm sorry, 1.2. Linear and rational equations. So for now, what do I know to put in my notebook? I know that the binomial squared is a
Trinomial.
excellent.
I wrote it right there.
Excellent. Then I know 3 special products, and I know how to address them. And I promise myself not to foil them because I know the pattern, and I can use the pattern for anything, correct?
Right.
Then I know what this means in the viewing window of the graphing calculator. Leftmost point, rightmost point, scale. Bottom, top, scale. And now I will look at linear equations. Yep. So now I would like you to choose a linear equation for me that you would like to go over. And they start, if you have your book, they start on page 120. And maybe I should choose the first one and then you choose the second one. So let's say problem 14. We have 5x. I make somebody in charge with making sure that I copy the correct problem. And not half from 14 and half from 15. I always have someone assign that task because when I go from left to right, I copy half of one problem, half of the other sometimes. My apologies if that happens. Okay, what type of equation is this? Remember, I have to identify the type of equation correctly because if I'm not capable to identify what it is, chances are that I have no clue how to solve. So what do you think about this equation? Obviously, it's an equation. Let me point out something very important. Every equation has only one left-hand side, only one equal symbol, and only one right-hand side. So please do not simplify to the sides and have 5 equal symbols in it. I will not look at it. Please. So that's why we write each equation on one line. So what type of equation is it?
Linear.
Excellent. It is a linear equation. How do I know it's linear? It's because the powers of the variable are all 1. Secondly, there are no denominators with a variable in the denominator, because I can have something like this. This is not rational. This is still linear, a linear expression. Okay, I don't need it right now. Good. So it's linear. There are no products of variables and so on and so forth. Good. So how do I address this? What do I need to do?
Get it on one side.
Not yet. But you're right.
Multiply like the outside, like the 5x.
So we first remove what? Excellent. So then 5x.
Becomes minus 10x. Oh no, we're not doing that yet, right? Okay. Sorry.
I'm distributing -1. I'm not distributing
Okay.
5x.
So 5x minus 2x
Excellent.
minus 2
Excellent.
equals x
Excellent.
plus 3x minus 5.
Excellent. Excellent step. Everything perfect. Now at this stage, and I will write this down in my notebook. How do I solve a linear equation? If there are parentheses, I remove them. Second step, I combine like terms. On one side, simplified fully. On the other side, simplified fully. I want you to write down 2 important keywords that if you decide to agree with me and follow my request of a notebook just for important information, you will put 2 keywords. Keywords in algebra. Simplify is one. Factor is the other. I will ask you a lot about which keyword works here. Sometimes both. Most of the time, the simplify keyword will work in all situations. Most of the time, unless there is nothing to simplify. At this time, we have to simplify both sides fully. Okay, the left-hand side is obviously 3x minus 2, and the right-hand side is obviously 4x minus 5. Here's what I recommend. This is our step 2 or 3 after we completely simplify both sides. We will move terms around. If you still want to continue writing minus 4x, and plus 2, and plus 2, that's fine by me. I will not. You stick with your method, I'm fine with that. I will move. What happens when we move a term from one side to the other?
The sign change.
Excellent. I prefer keeping the variable on the left. You can say, I want it on the right. Fine. There is no problem. But when I move 4x to the other side, it becomes 3x minus 4x is?
Negative 1.
Excellent. When I move -2 to the other side, it becomes? So -5 plus 2 is? Only now I divide, or multiply in this case, the same thing, by -1. We can never divide by the variable. Thank you. Note, it's okay. Never divide by the variable. We are solving for it. We cannot divide by -x or x, ever. Okay, so then what do I divide by?
A number 1.
-1. So then I get x equals, that's it. This is the way we solve. Oops, it's 8:31. I'm sorry, forgive me. I'll finish a minute early.